as we continue our review of some common functions you should be familiar with. And in this video, we're talking about logarithmic functions. Again, a lot of times, well, one place I know they're used is to model kind of your perception of loudness. Perception of loudness is measured kind of in a logarithmic scale. We talk about dBs of loudness. Anyway, let's look at this log base 10. These are inverse functions, another term I'll throw out that we'll get back to later. But you've heard that term, inverse functions of the exponential function 10 to the x. So the log base 10 of x, well, there's always one common term, one common place. Let's just graph this at, oops. Messed up here. Okay, so at 1, this is always true of these logarithms. The log of 1 is 0. Okay, and then as it grows up on this one, we know what? Well, we also know at 100 or at 10, you should know. 10 to the, and this is kind of what saying what? 10 to the what power? Okay. 10 to the what power is equal to 10. That's what this is. Okay. 10 to the 0th power is equal to 1. That's where you get that. 10 to the what powers? It's equal to 1. Oops. 1, sorry. I got to remember to turn off the recording. Okay, so anyway, at 10, it's equal to 1. And it does continue to go up, but slowly, right? Here is 10, and we get out to 100. Well, at 100, it's only at 2, okay? Now, what happens as x is less than 1? Well, it tails off. It looks like this, okay? It looks like this. So if you said, at -1, at 1/10, I guess this is, or if I go out at 1/10, 0.1 equal to -1. 0.01 is equal to -2. Anyway, so this is the shape here. You got to convince yourself. This is log base 10 of x. Notice a few things about here. What is the domain? The domain of a logarithm, x, is always greater than 0. Okay? Always greater than 0. There's the domain. What about the range? Well, the range is going to go from -infinity to positive. It does get to infinity here, but very slowly. Okay, how about log base 2? What's going to happen there? Let's change our color. How does that change things? Log base 2, it's still going to hit this part here. But now, at 2, it's going to be equal to 1. So it's... Okay, if we do log base 2, you see we still got this point here. We still got the point 1, 0. But now when we put in 2, we get 1. We get another point here at, let's see, at 128. You have to think about this. 128. If you know your powers of 2, you're at 7. Is that right? I think so. Yes. 128.7. So it goes up higher. It also crosses this way. So it has the same general shape. This here is what? Log base 2 of x. Now what about this? Log base e. We have a log, that special Euler's number, 2.714, we have a special notation for that. We call that the natural log of x. And you'll see E is what? Well, that's 2.714, somewhere between 2 and 10. So it's going to be in between here. We'll change the color, make it red, and we're going to just kind of draw it like that, and come bring it down like this, okay? This function here is then the natural log of x. Again, something you should know, but you should know as x, again, as x gets closer and closer to 0 from the positive side, the function goes to negative infinity. We'll talk about limits. And it grows as x gets bigger and bigger. It grows, but very, very slowly. It goes to infinity. Okay, now here we got a translation and a reflection. See if we can do that. Do we have a color left? We'll do it. Let's pull out a... Okay, this last one here. I'm going to pull out a pen that's crazy. I don't know what this is going to look like, but this is a natural log, but it's been moved over. It now happens at, it's going to be 2, 0, so it's going to move to the right. So this thing's going to be moving over here. Okay, and then it's going to be flipped. So this, if this wasn't crazy enough, I would, this curve right here is negative. Oops. Yeah, that's hard to work with. And let's try that. This is just the natural log of x minus 1. Now notice, it's going to have an asymptote here. It's never going to cross x equal to 1. And then, what do? I got to reflect it. I'm making this a little bit. Now I'm going to see this negative sign here. What does that do to it? Well, the negative sign then reflects it around this way. So I go like this, and I go like that. So that's a little bit messy here. But this function now, right here, is negative the natural log of x minus 1. Okay, hope you could follow that. I think that is about, oh, one more thing I want. Okay, the last thing I wanted to touch upon here is how to sketch, how to read a little bit was a composite function. And you'll see here composite function, meaning I've got a function of another function. Y equals function of another function. And we'll be looking at these a lot when we talk about chain rules and whatnot in calculus. But this might be the picture. Remember the machine drawing. I'm going to take a function, an input x. I'm going to put that input x through g of x. That's going to give me an output. That output then I'm going to feed through the function of x and get y of x. Okay, let's look at an example of a composite function and see how we could sketch this. So you see in the inside function, that always happens. In the inside function here, what I might call g of x, I've got x squared minus 5x. Now how would I draw that? Well, I see that that inside function is x times x minus 5. I factor that. So I know it's got a 0 at 0 and a 0 at 5. And I kind of know, I know how to draw quadratics. Okay? This is what function? This is x squared minus 5x. Well now, though, remember I'm going to slap a absolute value. Okay? So maybe, let's put this back here. Follow my other. This is equal to g of x. Well, what's f of x equal to? F of x, that's blue. F of x, the outside function, is just equal to the absolute value. Well, how do I take an absolute value? Remember, what an absolute value does is it takes anything that's negative and it makes it positive. So I'm looking at this graph now and I'm drawing it. Well, this is positive, so the absolute value does nothing to that. But now down here, this goes negative. So this negative value goes positive. This negative value goes positive. This negative value goes positive. And I think you might see that this now looks like this. Okay. And then, of course, notice this function, after 5, this is 5, right? This is 0. And when x is greater than 5, the absolute value does nothing. So there we go in blue. There's a composite function right here in blue. This is the function x squared minus 5x. Okay, that will complete the section on functions that you should know and be able to sketch. Now we will next we will talk about how to use our calculators to be able to look at functions and to gain insight into their characteristics.